There we go. Got it. This afternoon, as I mentioned, we're going to talk about some operational things. And what I'm going to talk about now has to do with water quality and water quality monitoring in shellfish farms. And I'm not going to describe any type of prescriptive thing that a shellfish farmer should do. What I'm going to talk about are some of the things that you may want to think about with respect to water quality, whether water quality monitoring could provide you with some value in your shellfish operation. And so what should be considered by a shellfish producer is that many of you may not monitor water quality other than temperature. That would be something that would be very commonly done, and maybe not. But ultimately, monitoring water quality could provide you with a number of benefits. Could give you an idea of whether or not your environment is stable, whether or not your environment is healthy. Could give you an indicator of spawning events if you collect spat fall. Could give you an idea of when your bacterial populations are going to be elevated, as we heard from Robin, with respect to specifically Vibrio. Give you an idea of whether or not you have freshwater influences or possibility of algal blooms. Could also give you some trends that could help you to identify the carrying capacity of your site, or provide you with some baseline data, some historical baseline data that you could use as you move forward to determine some management plans for your operation. So essentially, water quality monitoring can take you from being reactive to being proactive. So if you know the trends on your site, it may allow you to do some predictions with respect to some things that you should be thinking for in the future. So again, as I mentioned, I'm not going to be prescriptive because what you may want to monitor may depend on your site and the susceptibility of your site to different influences. So if you're close to a freshwater source, or if you're close to an area where you may have a lot of ice that could melt in the spring, you may want to measure salinity. I know an example of a producer that always has a tremendous amount of mortality in one area of the site. He has come to the conclusion that what happens in the spring, he gets a lot of ice, he gets spring runoff from the ice, but the fresh water is actually traveling under the ice and killing his oysters. But he's never monitored the salinity, so he has no idea if that's what's happening. So monitoring the water quality in some areas or on some sites maybe could provide you with information with respect to why some events are happening. If you're in a site with low turnover, as we saw from some of the speakers this morning, low turnover may mean phytoplankton or cestin depletion. So you may also cause low oxygen if you have a site with high sedimentation. So oxygen or chlorophyll may be aspects you might want to look at. If you're located in your farming operations, the sites in Tracadie Bay that we saw this morning, that we saw pictured so nicely this morning, they're in areas with a high amount of terrestrial farming, which is probably why the shellfish sites, the productivity in those areas are indeed that high, is because they have a lot of influences from the terrestrial farming in the area. So perhaps you'd want to look at nitrogen or phosphorus levels in your water. So let's look at some of the parameters that you may want to look at on your farm. The first is obviously temperature, and again, it's highly likely that you're monitoring temperature already. And why should we monitor temperature? Well, shellfish are poikilotheria, cold-blooded, ectotherms, whatever you want to call them. They can adjust their body temperature, so their metabolism is going to be reflective of the temperature of their environment. And as we all know, each species has a preferred optimum temperature range where it's going to grow best and grow most efficiently. So there are two things there to consider. It's not always best growth, but it's also efficient growth. We know that mortalities can occur at extreme temperatures, and also other things are affected by temperature, things like immunity, so resistance to disease, reproduction, or even feeding activity and things like that will be influenced by temperature. So scientists will describe the thermal tolerance breadth of an organism as that being the temperature range at which the organism will perform according to how you want it to perform. And you're going to have an optimum temperature, which is where the organism is going to perform at its best within this range, okay? So this is just a graphical description of where your critical lower temperature is, your critical upper temperature is, your performance of your animal is going to increase over this range, and then it's going to decrease quite sharply, possibly depending on what your organism is and how tolerant it is to different temperatures and things like that. And every animal has a different shape to this curve. So this is just an example curve of what that looks like.
Are those curves available for different species?
I tried to find one for oysters specifically, and I couldn't find one. So, because people often talk about that curve with respect to how well animals are going to adapt to climate change. So I think if I did a little more digging, I might be able to find something, but I wasn't able to find anything for today, but I'll keep looking. So.
Pretty much all started zero.
So the other things that you have to consider is everything in the water is affected by temperature. So it's not just your animals. You have algae growth. You have also respiration of algae. Algae don't just photosynthesize, they also respire. Okay, so you have two main processes that are happening with algae. It may also affect what type of algae you're growing, so whether or not you have an algae bloom or not. Will also affect the rate of bacterial growth and the respiration of the bacteria. If you have high sedimentation below your site, you have high temperature, you may have an increase in biological oxygen demand because of your temperature. May also allow selection of different populations of bacteria, may affect parasite growth and the type of parasites, similar for viruses, so that ultimately any biological organism in the environment is affected by temperature. And Robin mentioned Vibrio, the Vibrio species he was talking about. If you look at the Vibrio doubling time, he mentioned how quickly it escalates with temperature. At 10 degrees Celsius, the Vibrio species will double in 36 hours. If you look at 20 degrees Celsius, in 3 hours. So that's like a 10-fold increase in growth. So that's tremendous, and that's why his referral to temperature being so important is absolutely critical, because it's not a direct relationship. It is actually an exponential relationship between temperature and between growth. The other aspects that temperature affects includes the property of water. Probably the most significant one of these for aquaculture has to do with oxygen. As temperature increases, the solubility of oxygen decreases. So you can have essentially a perfect storm. The metabolism of your animals, of the other animals in your water is increasing while the solubility of oxygen is decreasing. So there's a simple curve, oxygen concentration on the y-axis, temperature on the x-axis. For seawater, shown in green, you can see that the solubility of oxygen decreases fairly rapidly with an increase in temperature. This may also affect total other gases in the water, solubility of other gases, as well as the density of the water. But oxygen is likely by far, probably the most important parameter that'll change. So temperature will affect the growth and survival of virtually all organisms and the property of water. I mentioned several times already about the impact of temperature and its significance from a human health perspective with respect to Vibrio we mentioned, also salmonella and algal blooms. So if you monitor your temperature, maybe you can predict before some of these things are going to happen. It may also provide some baseline data if you think you're seeing a change in your system or seeing a change in your site over time. If you have those historical records, it'll give you some idea with respect to perhaps where you may be going. It may also help, again, with respect to determining when you should collect spat. And obviously when to sink cages for winter and things like that, and assist you with respect to how you're deciding your flipping of your cages regime for your oyster grow out. So the next parameter that should be an option for monitoring is oxygen. We all know that we all need oxygen to survive, as all animals do. And oxygen is going to naturally vary within the environment, and that could be due to tides. It could be some type of a daily cycle. It could be due to wind. Just the same as we know that the cestin will get replenished and things like that. Similar to the oxygen will get replenished and will vary throughout the day, as well as throughout the month, etc. And also there may be other influences that could affect the oxygen levels in your water. Well, this is just sort of an example of how things can interact within an ecosystem so that your different water quality parameters sort of build on one another. So if you have high water temperatures, you have low oxygen solubility. If you have that combined with heavy rain so that you have a lot of nutrients input into your water, and then suddenly you have an algal bloom, you have high ecosystem metabolism, so you have high oxygen consumption from your animals, you have an algal bloom, so you have a high oxygen consumption, particularly in the middle of the night, or when your algae are respiring, when they're not photosynthesizing. And this is all hitting at a time where you have low oxygen solubility. So again, you could have a perfect storm event, low oxygen solubility, high oxygen use. So that can have an effect, obviously a double negative effect. So changes in oxygen may also be an indicator that something has happened in the ecosystem. Maybe you've hit that tipping point where the guy's falling over the cliff, you know, that we saw described this morning. But oxygen monitoring should bear in mind that it should be done around critical time periods. If you can only do it at certain times, be smart about when you're selecting for doing your monitoring. Do it when you think your oxygen solubility is going to be lowest, metabolism of all the organisms in the water are going to be highest, or at times when you think oxygen could be limited for other reasons. So salinity is another water quality parameter that is likely mostly impacted by freshwater runoff. In a facility that I was responsible for in the spring, it would not be unusual to see a salinity drop from 28 parts per thousand to 18 parts per thousand because of ice melt, in particular in the spring, and that's quite a significant salinity shift that somebody could be aware of, should be aware of. And as I mentioned, the producer who was losing the oysters, if there's fresh water running over your oysters in the spring due to a runoff, could be killing your animals one year and not the next, just depending on your water parameters. So monitoring for salinity could give you some answers to those questions. It's always good to know what's normal in your area, and having some kind of a baseline will help you to determine trends with respect to your area. When would salinity be a concern? When should you monitor? When should you be concerned about your animals? pH in the ocean, typically fairly stable. Normally fluctuates between 7.5 and 8.5, but it can fluctuate seasonally as well as during the day. We know that humans are producing CO2, and what's happening is it's getting into the marine environment and it's actually shifting the pH of the ocean. Some areas are more rapidly affected than others. This is the graph of some monitoring that NOAA is actually doing, I think it's in Hawaii. And so what they've actually been able to do over the past 60 years is they've been monitoring atmospheric levels of CO2, which is the red line. They've been monitoring this levels of CO2 in the ocean, which is these light green points. And concurrently, they're monitoring the pH of the ocean. So we can see a very clear and distinct decrease in the pH of the ocean as the CO2 production in the atmosphere is increasing. So that is having some pretty significant effects on the West Coast with respect to recruitment of shellfish, and it's something that we need to be aware of on the East Coast as well. Nitrate is a water quality parameter that may or may not affect you, again, depending on where you are and whether or not you have some terrestrial influences. Most marine environments are nitrogen deficient, which means that the algae growth is limited by the level of the nitrogen in the water, which is why nitrate levels in the ocean is very important, okay? So that may be the limiting factor with respect to whether or not your algae is blooming, which makes nitrate something that you may want to consider monitoring. Chlorophyll may give you an idea with respect to shellfish food supply. Again, we heard this morning about the monitoring of chlorophyll to give an indication about whether or not you have exceeded the carrying capacity of your site. So this may be something that if a site is being assessed for its usefulness or for its carrying capacity or something like that, you may wish to monitor for this, and perhaps monitoring for this relative to growth of your animals as well could give you an idea with respect to what your carrying capacity is. I'm not going to go through this. What I wanted to do these are within your presentations, is to give you an idea of some of the options for monitoring some of these things. Some of these are more accurate, some of these are less accurate, some of them require some technical ability, some less. So just to give you an idea with respect to some of the ways you can monitor different things, in case you choose to investigate one of these parameters to monitor. And ultimately, there are a lot of options out there, and these are getting more and more sophisticated as technology keeps up with the times, and lots of remote monitoring capability. In fact, I was at a finfish farm this week. Everything is done remotely with optical sensors for oxygen and in real time. Somebody can sit at their office in Bridgewater and know what their farms are doing in Digby. So a lot of sophistication has really entered this realm of water quality monitoring. May not be right for you if if you have a shellfish farm literally in your backyard and it's your farm, but just to give you some idea with respect to the differences in the levels of sophistication. One thing that I did want to emphasize before I finish is that any piece of equipment or testing method is only as effective as the person who's actually doing the sampling, and is only as effective as how you're doing the sampling. So you need to know what equipment, make sure that it's appropriate, make sure it's being used properly, if it's not calibrated properly, if it's not being used in the right environment, if your oxygen meter isn't set to the right salinity, just some little things like this. You have to make sure you're using your equipment properly so it gives you accurate measurements. Also, the place that you're doing your water quality monitoring is very important. You want it to be representative of whatever you're looking for. Are you looking for lows in oxygen? Well, then you should put your oxygen meter where you think your lowest oxygen level is going to be, and things like that. Should also make sure that when you're measuring your water quality parameter, you're doing it consistently in the same way every time, so that if you get a variation in your reading, it's not because you're doing something differently, it's because you're actually seeing a variation in your reading. And as I mentioned, very important that your equipment is used properly, that it's calibrated and clean. There are many membranes that are used in water quality monitoring equipment that get fouled very quickly. So you also have to sort of weigh the pros and cons of how much you want to monitor, because some pieces of equipment take an awful lot of maintenance and may not give you value for what you're actually looking for. I just listed some supplier options. I'm not promoting these suppliers or anything, but what I did want to emphasize is that the Department of Fisheries and Aquaculture in Nova Scotia, they do have water quality monitoring equipment. One that I've used in the past has been the temperature probes. Robin mentioned the Hobart temperature probes. There are other temperature probes and things like that as well that you can borrow for a period of time, and they will download the data and give it to you. They also have current meters that I think are being employed here in Nova Scotia within some aquaculture sites for use. They have a lovely ROV that I got to see last week, and they have underwater cameras as well. And although they have a busy field season for environmental monitoring, they do have some time with respect to if you have a question or if you want some help from them in order to use some of this equipment, they may be able to offer it for you. So I won't promote the other suppliers, but I will promote that service, which could be available to you if you ask the right question to the right person. Any questions? Yes?
Has there been any discussion, I guess, on just talking about tools and monitoring methods to develop a tool library that you can borrow from maybe regionally or something that people can access more easily?
So interesting, 2 years ago, we tried to set that up through the ANS actually, but that actually it just sort of fell into the cracks, because that was when we were shifting executive directors. That was before you came on, Tom, and things like that. So there has been talk. My suggestion is if you're looking for a piece of water quality monitoring equipment, we talk to the province. I've used their gas meters, I've used oxygen meters, and the fish health unit has some meters that are available for use and things like that. So, but if there's a demand in the industry, that maybe should be something that we could talk about with respect, because I know what you mean. Would be nice to have a reservoir meter so that you can use, as long as people are following the right biosecurity protocols to make sure we're not spreading anything around. So, yeah. Peter?
Over the year, I bet you I've had 50 different people, scientists, come out and put pieces of equipment on our site. I put 2 temperature and salinity probes out yesterday for BIO. I never get the information, and I never see the information, and I think that information should all be very, very public. And maybe ANS or someone coordinate just the amassing of that information, so at least it's there in one place, because it disappears. The work gets done, but nobody ever sees it, and all those scientists are working in silos, and they don't even talk to each other.
But Isabel and I have actually talked about that because we talk about big data. There's actually a conference going on in Halifax this week about that, and the fact that you have so many people who are collecting their own little bits of data in their silos, including producers who are out on the water every day collecting this data. Wouldn't it be nice to have a bank, right? So that you go to Nova Scotia, let's go here and see what information is available. And let's go to here and see what information is available, because I don't have any doubt that that information would be of incredible value to scientists, to producers, to whatever. Jeff talking about who reports the invasive species, it's the producers. They're the folks who see them. So everything from water quality to invasive species to things like that, or to observations on the farm.
Also for, targeting some places to develop the aquaculture, leases or things like that. I know I was in touch with the province at some point to have historical recording in some targeted area to see if we could compare what we were measuring now versus before. And, if we are to grow the industry, we should take advantage of that big collaboration in order to, not doing again and again monitoring some area if it has been done, and if we can compare, if it's too old, then we can compare what's going on now, if it's still stable, if it's a good place to go and develop the industry. But anyway, we'll have a talk about it.
Yeah, I'm glad you brought it up, because that was something that, again, Isabel and I have been talking about. Thanks, Nolan. We've been talking about it and sort of wondering, well, is this really, it makes sense, but is there a real need for it? So that sounds like that, yeah.
Is there
Well, is there a demand for it? Is there, because you don't get funding unless you have a demand for something, right? And so.
Then also, I know what you mean, some scientists are coming on leases and they have projects and they don't necessarily, the association or the province are not necessarily aware of all the project and what's going on around the province. So it's a matter of promoting and getting everyone that is involved around the province in different project to contribute to that project, because we cannot.
but it doesn't happen now.
No, it's
Not
not
always
happening
anyways.
right now. No, it's
No,
not.
it doesn't, and it should.
That's true. And, go ahead.
There's a
Go ahead.
database, where DFO is supposed to put those data sets.
Is there?
Yeah, there's the
Do you know where
coastal
it
time
is?
series. It's online. It takes a lot of digging.
Yeah.
But it is there, and there's lots of old data, but I don't know how often they update it. I haven't looked in a few years. I don't know. It's pretty sparse, so, who's to say whether your specific data is up there? And there's another group that's doing something like that called Coin Atlantic.
Okay.
And the Atlantic Canada, Atlantic